I'm a 4.0 pre-med, and one thing about me is I study smarter, not harder. I make mnemonic techniques to maximize my studying every day and hopefully help you do the same. So welcome to my channel, and today we're going to be talking about conformations of alkanes. So I know this seems really daunting because when I was learning it, I thought it was super daunting too, but it really isn't that bad, I promise. So this is what you call a Newman diagram, and I probably should have drawn it, but I didn't. Is when you have some type of molecule, right? So like in this case, you'll see like a CH3. This is probably butene. So then you're gonna grab that molecule and like put what you see. So here you would see 2 hydrogens. Here you would see a CH3. And then here you would see another 2 hydrogens. And here you would see another CH3. So yes, this molecule is butene. And again, you're gonna look down upon, and so like you choose where to cut the molecule, but I specifically chose here because as you can see I have a CH3, I have 2 hydrogens, and so it only makes sense that I have a CH2 here to have my 2 hydrogens connected to a CH3. Likewise, if I have a CH3 in the back that's connected to 2 hydrogens, because all of these are in the back, then it only makes sense that I have a CH2 and connected to a CH3, so this is butene. Now, speaking about conformations and all of that, I want to make the point that you have different ways of arranging the molecule in space. So, and like I wrote down, different arrangements of atoms from rotating bonds. So let's get some vocabulary in. So this right here is considered the dihedral angle. So here it would be 60 degrees. But again, I don't know if I wrote it over. Oh no, I didn't. I'm gonna make another video on this about specifically like the energy diagrams and stuff, so that way you'll be able to see. But again, this is just kind of like an introductory video. And so staggered is when you are not stacked on top of each other. For example, eclipse, you're stacked one on the other, and technically I put like this little space, but you wouldn't have that little space. That little space is for you to actually be able to see that you have something behind, but literally it would be stacked one on the other. And that is why that has a lot of steric strain energy. I put 19 kilojoules per mole. This one is also eclipsed, but it's a little less energy, and you're gonna be like, why? Well, this one is a CH3 and a hydrogen. These are 2 methyl groups, and so if your R group, like the bigger your R group, and if you put 2 R groups that are big together, you're gonna have more steric strain. Versus if you have like a methyl group and a hydrogen, or an ethyl group and a hydrogen, is better than putting an ethyl and a methyl, or an ethyl and another ethyl. And then you have gauche. So here is an example of gauche, that you have your 2 R groups. Gauche really means left in French, so think of it as this is to the left of it. But so yeah, that's gauche when your R group is adjacent to it, but you still have a little space. Anti-conformation is when you're 180 degrees. And so I'll show you, like I said in another video, of how that angle rotates. But again, this was just an introductory. One more thing that we should talk about before I conclude this video is that if you look in terms of stability, and I cannot say that this will always be the case, because like I said, I'm pre-med, I'm studying for the MCAT, and there are cases that anti-conformation is not the most stable. And you're going to say, why, and why is that? For example, if something makes a hydrogen bond, per se, then that would be more stable. I saw that, I think it was an Eclipsed, and I was extremely surprised. And I went and to my organic chemistry professor at the time, and I was like, you lied to me. You told me it was always anti. She said, this is an extremely rare case that you have a hydrogen bond. So in general, the point of that story is that in general, anti-conformation is the most stable. After that would be just a regular staggered position, for example, like the Gauche that you saw. Then it would be the eclipsed with the least amount of energy, and usually that eclipse is the R group with the hydrogen. And then the eclipsed with the two R groups stacked on top of each other is the most unstable and the most energy, because it has the most steric strain. So again, I tried to draw it, but I'll highlight it, I guess. So if you go from here to here, this is least to most stable. Now if you go from here to here, that is going from the least strain to the most strain. Again, if you enjoyed this video, please follow and check out. Go to my YouTube. I have everything on playlists like organic chemistry and chemistry, etc. And so I have all of the videos related to that subject on there, so go check that out. And thanks again for watching.